Next is the chemical properties of haloalkane. There, the reaction of the reactions by haloalkane can be categorized into 5 types. There, first one is the nucleophilic substitution reaction. Second one is elimination reaction. Third one is reduction reaction. Fourth one is reaction with the metals, and fifth one is the rearrangement reactions. So these are the 5 types of reaction that we are going to read in the chemical properties of haloalkane. So first we'll go through which one there. Nucleophilic substitution reaction. As it is clear from the word itself there, that is it is attacked by a nucleophile, and there which kind of reaction takes place there? Substitution reaction takes place. Which kind of substitution reaction? Now look at here. The substitution reaction means removal of one thing in place of one thing, that another thing will take place there. Now here what we say there, see this structure of haloalkane Rx. R is refers to what there? Alkyl group. X is refers to an halogen there. When a nucleophile comes and attacks towards this bond between this R and X haloalkane there, now what happened there? This nucleophile has been form a bond with what there? Alkyl group, and where forms another product, and leaving behind what there? Halide ion. So this is the nucleophilic substitution reaction. Here the order of reactivity also follows the order of reactivity would be a different there. So the bond dissociation energy, we are talking about the fluorine over there. It is the bond dissociation energy will be maximum there. Then chlorine, that is about 330.5. Then bromine, that is about 276.1. Then what you can say about the iodine, that is 234.0 there. And the order of stability we are talking about here. So which one is the maximum over there? So the what we can say there, reactivity. Then iodoalkane will be having the most reactive one, then the bromoalkane, then chloroalkane, then fluoroalkane there. Because the iodoalkane can their bond energy will be very much less. They can easily broken down with the help of smaller energy also there. The order of reactivity for the same halogen if we are talking about there. So order of reactivity depends upon what there, the number of alkyl group attached to the halogen over there. If the number of greater is the reactivity, higher the number of alkyl group attached to the carbon of the CX bond, greater is the reactivity of the haloalkane. Because alkyl group here present in which what there, it is an electron repelling group. See, the higher number of alkyl group are more in the display, more is the displacement of the shared pair of towards the halogen atom. See here in the case of tertiary atoms, what happened here? Tertiary haloalkane, it contains the three different alkyl groups over there. These three different alkyl groups have the tendency to repel the electron, and they will repel towards which side there? Carbon, and carbon will repelling the electron toward which side there? X. So in that case, the tertiary haloalkane will be very much reactive, then the secondary haloalkane, then the primary haloalkane. Then they are going towards the reactivity of which one there? SN1 and SN2 type of reactions there. There are 2 types of reactions following this one there. One is of SN1 reaction and SN2 reaction. What is this one? SN1 reaction and SN2. SN1 is what there? Substitution unimolecular reaction there. Here the SN2 refers for what there? Substitution nucleophilic bimolecular reaction. Here SN1 reaction mostly follows this one order there. It will found mostly in the tertiary, then secondary, then very less in the primary there. But we are talking about the SN2 reaction, they are mostly found in the primary, then little bit in the secondary, and very less in a tertiary. See the mechanism how it will take place in SN1 and SN2 reaction. SN1 reaction is generally takes place in 2 steps there. How it will take place in the 2 steps? I told you there SN1 reaction is taking place mostly in the tertiary compound there. See here, carbon is attached with the 3 different alkyl groups there, R1, R2 and R3, and along with that what happened here, when this carbon atom, these all 3 are what their electron repelling group. They are repelling the electron towards this carbon, and carbon is repelling the electron towards X. So in the first step, the older bond will be broken down there. So in the first step, the older bond had been broken down, that is X had been released out there, that is step 1. and it is a very slow step. In the next step, what happened now after releasing this X electron, this carbon is having a positive charge, and it is also called as carbocation. And now this carbocation along with this nucleophile, when this nucleophile comes here and attack this one, which one, there, carbocation there. Carbocation have the tendency to attack the negatively charged particles, and they will form a new product there, and that is in the second step. Now here what we can say that first step is what in which the older bond had been broken down. In the next step, the new bonds had been formed up there. So generally what we can say that the SN1 reaction takes place in the two steps. The first step, older bonds had been broken down, and the second step, the new bonds had been formed down. And the first step should always be slow, and the second step will be much more faster there. And the slowest step in this steps of the reaction there, and the slowest step will be the rate determining step there. Here the first step will be the slower one there, so it will be become as the rate determining step, means which gives you about the rate of reaction.